Imagine peering back in time to witness the universe's wild infancy, a chaotic era of exploding stars, burgeoning galaxies, and the dramatic shift from darkness to light. That's the epic tale unpacked at a recent conference in Australia, where astronomers gathered to decode the first billion years of cosmic history. But here's where it gets controversial. Are our current models of the universe's early days holding up, or do they need a complete overhaul? Join us as we dive into the insights from this gathering, and prepare to question everything you think you know about how the cosmos ignited. From October 22 to 26, 2025, approximately 80 astronomers from across the globe converged in Port Douglas, Sunyaev-Zel'dovich, Australia, right beside the stunning Great Barrier Reef, for the Exploring the First Billion Years of the Universe event, available at https://www.conference-eor.com. Despite the arduous travel for many participants, the warm Australian hospitality and breathtaking scenery swiftly underscored why this spot ranks among the planet's most idyllic venues for such encounters. Over the course of several days filled with presentations and beachside chats, scientists exchanged cutting-edge discoveries about distant galaxies. Check out https://science.nasa.gov/mission/web/early-universe, quasars, detailed at https://isarhubble.org/wordbank/quasar. The 21-centimeter line of hydrogen, explained at http://hyperphysics.phy-rstr.gsu.edu/hbase/quantum/h21.html, the reionization process, explored at https://cosmicdawn.astro.ucla.edu/epoch of reionization.html, and the cosmic microwave background, CMB, as described at https://www.esa.int/science-exploration/space science/cosmic microwave background UNDCMB radiation. This summit stood in stark contrast to a prior event hosted by the Choir Collaboration in Maine, USA, earlier in the year, a week down east, challenging assumptions about galaxy evolution, which we covered in a previous Astrobite. See https://rstr.bits.org/2025/08/choir-conference-2025. Both gatherings took place on lands that were never formally ceded by indigenous peoples. In Port Douglas, Sunyaev-Zel'dovich, Link Walker. Learn more at https://lithoq.com.au/board-members/Lindsay-Walker, a traditional custodian of the local Kuku-Yalanji community, delivered the welcome to country address and a smoking ceremony, weaving in narratives about the area's history, struggles faced by indigenous groups, and even practical advice on steering clear of saltwater crocodiles. Just a couple of weeks afterward, a crocodile turned up in the swimming pool of an adjacent luxury resort, as reported in https://www.theguardian.com//video/2025/2020/crocodile-discovered-in-luxury-pool-video. Fortunately, no injuries resulted. This Astrobite piece is crafted by students and conference goers, with guest contributors and organizer Sabrina Berger listed in each section's credits. The complete schedule, including talk summaries, is accessible here, https://docs.google.com/spreadsheets/d/1v4jjg0d8bqqyklj7l1n yari-movies5i-tf5rs@c/edit?mark us b=sign sharing. Galaxies, Day 1. Authored by Alice Ferreira and Sophia Jerries. The opening 2 days centered on the origins, development, and environmental impacts of the universe's initial galaxies, examining how tools like the James Webb Space Telescope, JWST, detailed at https://science.nasa.gov/mission/web, the Atacama Large Millimeter Array, ALMA, at https://www.almaobservatory.org/en/home, and advanced computer simulations are revolutionizing our understanding of the cosmos's earliest chapters. presenters delved into the rapid growth of the first black holes, the emergence of primordial cosmic dust, and a vibrant depiction of the universe's toddler years. Observations I, Seeing is Believing. The conference launched with a series of speakers sharing thrilling updates on recent observational data concerning galaxies from the distant past. For instance, Dr. Yuichi Harikane, invited presenter from the University of Tokyo, illustrated the unique yet synergistic viewpoints offered by JWST and ALMA data on the characteristics of ancient galaxies. This could significantly influence our interpretation of the roughly 300 potential JWST-detected galaxies at redshifts greater than 9.5, as presented by Hollis Akins from UT Austin. Wei-Yang Liu from the University of Chinese Academy of Sciences introduced an early dark energy model. Learn about dark energy at https://science.nasa.gov/dark-energy, as a potential rival to the standard Lambda CDM framework. Covered in https://rstrbits.org/2025/01/06/lambda_CDM, which might account for the abundance of these high-redshift objects we observe. Reionization I, Lyman-alpha emission. Reionization represents the pivotal period when ultraviolet light from the first stars and galaxies transformed the neutral hydrogen filling the young universe into an ionized state. Lyman-alpha, for a beginner-friendly explanation, see https://rstrbits.org/2018/how-to-diagnose-the-light from early galaxies, serves as a key ultraviolet spectral signature from hydrogen atoms. It gets absorbed by neutral hydrogen but passes through ionized regions freely. Detecting this emission therefore signals the presence of ionized zones that let UV light escape to our telescopes, while neutral areas block or diminish it. Dr. Uris Wittstock from the Cosmic Dawn Center announced Lyman-alpha detections at around redshift 13, pointing to an astonishingly early onset of reionization. Meanwhile, Dr. Laura Pentaricai, invited speaker from INAF, explored JWST's role in identifying which galaxies were the primary producers of ionizing radiation. Drawing from a low-redshift Lyman continuum survey, more on that at https://en.wikipedia.org/wiki/Lyman continuum photons. Amanda Stoffers from Cambridge University developed an innovative modeling approach to accurately gauge the escape of ionizing photons from galaxies, aligning well with JWST findings. Fascinatingly, Dr. Cody Carr from Zhejiang University discovered that galaxies with more intense radiative feedback, explained in https://rstrbits.org/2022/03/some-constructive-feedback-on-feedback models, release a higher proportion of these photons, while swift galactic outflows. Detailed at https://users.obs.carnegie-cience.edu/tilde-mr/galwins.html, tend to confine them. Building on this, Dr. Hiroya Umeda from Tokyo combined 581 JWST spectra across redshifts from about 4.5 to 13 to investigate reionization, pinpointing UV-luminous galaxies as major contributors to the process. Observations 2, stars, gas, and early galaxies. Attention then turned to the intricate relationships between starbirth and the evolution of primordial galaxies. Dr. Carl Glazebrook, invited speaker from Swinburne, highlighted how the swift emergence of dormant galaxies within the universe's first 2 billion years defies predictions from Lambda CDM cosmology. Dr. Themia Nanarakara from Swinburne suggested that active galactic nuclei, AGN, as described at https://web/science.nasa.gov/science-overview/science-overview/active-galactic nuclei, might be key players in this puzzling scenario. Josephine Bagjen from Yale discussed little red dots, LRDs, compact, reddish, far-off sources spotted by JWST, and proposed that some could stem from extraordinarily dense galaxies where light is dominated by an older population of stars, rather than an AGN. Dr. Melanie Carsonen, invited speaker from ANU, revealed that intensely star-forming galaxies from the reionization epoch harbor centrally packed, dense, and turbulent cold gas, which contradicts current models of rapid gas